Okay, good morning, ladies and gentlemen. We have something very unusual this morning. Usually I'm the one who introduced the speaker, but this morning I'm the speaker and there doesn't seem to be anybody around to introduce me. So I've been given the job of introducing myself as well, which is very unusual. So forgive us for that. My name is Dr McKinnell. I'm the Managing Director for the Space Science Program of the South African National Space Agency, which I think is an amazing title, even though it's very long. So MD for SANSA Space Science for short. And my staff convinced me that it was about time that I gave the public lecture at one of our events. And they also convinced me to talk about a subject that I haven't spoken about before. So you have to forgive me, but I've done a lot of research and it's a very interesting subject and I hope that you will find it very interesting as well. So without further ado, welcome to SANSA, welcome to our open day. Thank you for supporting us. We're going to start off, we're going to talk about space spin-offs, how space technology benefits our daily lives. Working for a space agency, the question I get asked a lot is, why should we invest in space? Why is it necessary for a country, particularly a country like South Africa, to invest in space? And how has space benefited mankind? When we think about food security or poverty, etc. And so this is a topic that we often refer to as the value proposition of space. And so I'm going to give you some indication today. Obviously, in 45 minutes I can't cover the entire subject, but I'm going to try and give you some indication today of where we've benefited from space. And my table of a sorted array of stuff over here is going to help me to bring the message across. The first thing is, what is space? Now, everybody has a different idea of space. If you say you work for the space agency, most people say South African NASA, because everybody knows NASA. And I will admit right at the very beginning of this talk that I drew a lot from NASA. They became my best friend over the last couple of weeks because they have done an enormous amount of work in looking at the spin-offs from space. So we first start off by looking at what is the definition of space. Now, if you go to, I'm sure most of you have a friend called Google. And if you go to Google, you go to Wikipedia and you type in space, you get all sorts of things. A set of elements or points satisfying specified geometric postulates. Okay. Now, if you're a mathematician, that probably makes a lot of sense. If you're not, you're wondering how can that have anything to do with space? The infinite extension of the three-dimensional region in which all matter exists. Okay, that also sounds very mathematical and maybe not quite what we had in mind when we talk about space. The expanse in which the solar system, stars and galaxies exist, the universe, the region of this expanse beyond the Earth's atmosphere. That sounds pretty much like what we do, really, actually. But then it also says that space is a blank or empty area. And that space is an area provided for a particular purpose. So I'm going to reserve this space for my friend, for example, or something like that. Reserved or available accommodation in a public transportation vehicle. Save me a space on the bus. Also, and all of these come under the definition of what is space. Sufficient freedom from external pressure to develop or explore one's needs, interests, and individuality. Please give me my space to do my thing. Okay, that's also space. And it goes on and on and on. I had pages and pages and pages of the definition of space. I should have probably done that before I decided to become a space scientist, right? And then I could have chosen which one. Anyway, no guesses, no prizes for guessing which one we're going to use today. The expanse in which the solar system, stars and galaxies exist, the universe, the region of the expanse beyond the Earth's atmosphere, everything up there. So in this facility that you're visiting today, we study space between the Earth and the Sun. And we call that near-Earth space. If you go and look at a picture, you're probably wondering what is my definition of near, but I'm not going to go into that. Yeah, in space science, near is between the Sun and the Earth. Okay, so that's what the definition is that we're going to use. The space environment, then, is the environment between the Sun and the Earth. And it's the environment that we're going to talk about today. It's how do we use that environment. It's not owned by anybody. Okay, it's controlled by legislation, but I'll talk about that a bit later. It's not owned by anybody. It's there. It's very usable, as I'll explain in a minute, but it's also a harsh dynamic environment. And one of the points that we want to make in this presentation is that space, there is more space in your life than you think. So not only the space next to you or the space that you've asked people to leave you to create your own individuality, but in everyday items that you use at home, in everyday issues that you tackle, in everyday bits of technology that you use, space is there. It's been brought to you by space, and space being the space environment. And so that's what I'm hoping to get across to you today. Right now, one of my favorite people to quote is the 35th US President, John F. Kennedy, who was president from 1961 to 1963. He wasn't fired. He was assassinated. That's why he was there for such a short period of time. And he had a lot to say about space. And those of you who know your history will know that the space race really started in the 1960s, late 1950s, early 1960s. And John F. Kennedy had a lot to do with the space race and how the US started in that race. One of his famous quotes is, "The exploration of space will go ahead, whether we join in it or not, and it is one of the great adventures of all time, and no nation which expects to be the leader of other nations can expect to stay behind in the race for space." And many, many people have used that quotation as they have shown what the US and what NASA has done in leading the world in terms of the technology that we got from our race to be the first in space. Another famous quotation of his is, "We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills, because that challenge is one that we are willing to accept, one we are unwilling to postpone, and one which we intend to win." When we started the South African Space Agency on the 1st of April 2011, I used that quotation quite a lot in terms of motivating my staff that what we are going to do now by becoming a big fish in the South African space industry is not an easy road to choose, but it's one that will benefit us incredibly down the road. And that was one of the things that John F. Kennedy said when he passed the bill that resulted in the first man on the moon. And the video we were showing, which is actually done by a South African band called Goldfish at the beginning, is the original footage from the 1969 moon landing. And that was the result of that. And so I've used US quotes because I've actually taken quite a lot from the US. And then to move on, what do we mean by space spin-offs? Now, a lot of people have a lot of different ideas about what it means. For me, it's really about value proposition from space, but there are some definitions. So any product that is an adaptation, outgrowth, or development of another similar product, or a secondary or incidental product or effect derived from technological development in a somewhat unrelated area. And I seem to have forgotten to put any punctuation in, so whew. Right, so that's the definition for spin-off. And normally one would say a company is going to spin off or something, or a product will spin out of this particular idea. NASA developed the terminology NASA spin-off, which later became known as space spin-off, as a technology originally developed to meet NASA mission needs that has been transferred to the public and now provides benefits for the nation and world as a commercial product or service. They produced, for the last 40 years, they have produced a book which is about yay thick every year called NASA Spin-Offs, and it describes the technology that has come from what they've needed to do to be part of the space race. And some of those things I'm going to demonstrate to you now as well. There's also a website, I'll give you the link at the end if you're interested, where you can go and it's a database. You can go and look up any product and find out how it was used in space, whether there was anything derived from space that made it better, etc. They've really done quite a lot of work on this. So this term space spin-offs is now utilized by global space agencies to mean technology inspired by space-related requirements or companies that have been incubated by the space industry to provide further benefits to the nation. So NASA, they actually look at products that come from space. And for example, there are 4 very good products that came out of the Apollo mission that ended up with Neil Armstrong on the moon. But DLR, this German space agency, for example, they use space spin-offs to mean that they've incubated companies and small businesses that have come out of things that they need for their space industry. So it depends on exactly how you look at it. But today we're going to talk about, first my presentation will cover spin-offs. I've got 9 commercial consumer spin-offs that you would have come across in your everyday lives or your homes that have come from the space race or been utilized in space in some way. And then I'm going to look at a little bit more high-tech spin-offs that have come from some of those other space agencies. And then I'm going to talk to you about the South African spin-offs, what we've done in South Africa that has come out of our mission to join the space race. Okay, so NASA celebrated 50 years in 2008, and the NASA administrator, now NASA administrator is the equivalent of the SANSA chief executive officer. It's the big guy at the top, or girl at the top, big person at the top. And the NASA administrator at any speech said that we see the transformative effects of the space economy all around us through numerous technologies and life-saving capabilities. We see the space economy and the lives saved when advanced breast cancer screening catches tumors in time for treatment, or when a heart defibrillator restores the proper rhythm of a patient's heart. We see it when weather satellites warn us of coming hurricanes, or when satellites provide information critical to understanding our environment and the effects of climate change. We see it when we use an ATM, or pay for gas at the pump with an immediate electronic response via satellite. Okay, this is the US, right? We haven't quite got there yet. Technologies developed for exploring space are being used to increase crop yields and to search for good fishing regions at sea. And every time you look at what NASA have done and what has come out of their investment in space, which is billions and billions of US dollars, you will see that that's what's behind it the whole time, is how can we then go and use this again to produce something that makes the man on the street's life easier. Okay, then without further ado, let's look at some of those products. So consumer spin-offs. And I have a whole table full of consumer spin-offs here. And I'm sure you're wondering what a baby bottle, the Dustbuster, and a tire. And by the way, this is a Goodyear tire. Okay? And I'll explain in a minute what I mean by Goodyear tire. Have in common with NASA. Let's start off with the Goodyear tire. So, Goodyear worked with NASA on the Apollo mission in the 1960s to develop fibers and tire technology that resulted in rubber that was 5 times stronger than steel. The material increased the tread lifetime. And this started with the Apollo mission, and then in 2002, they utilized some NASA software, very, very fancy software, to improve the design elements and the production. And so when you drive on, I listened to a NASA guy called Jim Adams giving a similar talk, and his comment was, when you drive on Goodyear, you're driving on NASA technology. So we can thank, you can thank the space race for the good tread of your tire. And I thank our staff for finding somebody to lend me a tire this morning. Right. Then, does anybody know what this is? Anybody remember this? Yes. Right. For those of you who are much, much younger than me, okay, this is a vinyl record. Actually, this is Pink Floyd, by the way. I don't know if we have any Pink Floyd fans in. Okay, it just so happened to be Pink Floyd, right? So, and no, NASA didn't invent the vinyl or take a turntable to space. But what they did do was they needed lubricants that could help with friction when they went to space. And so the lubrication technology, something that came in a little bottle like this, was developed for a series of NASA satellites, produced a commercial product for protecting the sound fidelity of the records called SoundGuard. It was a spray-on fluid that deposited a microscopically thin protective coating which reduced friction. And it prevented the hard diamond stylus, so the stylus that actually went round and round and round and you hope didn't scratch your record, from wearing away the softer vinyl material of the disc. So the reason you could play these discs over and over again was because of a fluid that was developed by NASA. Okay. One day we might go back to. Yeah. Right. Then I couldn't bring a life raft. Sorry. I tried. I asked my staff. I asked my husband even if we could bring a life raft, but the answer was no, just use your hands and describe it. Okay. So this was quite an interesting story. The life raft, initially in the Apollo mission, what would happen was when the astronauts came back to Earth, they would dump them in the ocean. Okay. And then they would dump them in the ocean. They would climb out of their capsule and into a life jacket, and then a helicopter would come and fish them out. It was a bit of a wet experience. And as somebody once put it, it would be a real shame to be the first man to walk on the moon and then drown in your own ocean on your way home, right? And so what would happen was that as they were trying to climb into the life raft would tip over, and they would be bobbing all over the place, and the helicopter would actually have trouble trying to pick them up. So they would end up floating around for a while. So NASA developed a life raft that had a flapper valve that admitted water and moved with a wave action. And so the raft could not overturn even if all the occupants shifted to one side. So it had a piece at the bottom that opened as it landed, filled with water, and then closed again. So it became buoyant. And the people stayed on the top. And then the helicopter could just come and pick up the whole raft and move them to safety. Right? And so there was a lot of work done on this, and when I read about it, there was a lot of work done later on with it as well to improve the design. But basically, the raft now had the ability to right itself if it accidentally inflated upside down, and it's used. The same design is used in several conventional life rafts today. So also, if you go and Google life rafts, you will see similar designs to the one I've got there. Sorry, the picture's not that great. But basically, the original design was to save the Apollo astronauts from drowning. Okay, then we have some gloves. Okay, these gloves are supposed to be ski gloves. Please just imagine nice, big, thick ski gloves. These were the only ones I could get this morning. Okay, gloves and boots. Okay, this is actually quite a thermal boot. This is one of the boots. There's the other one is somewhere else that is used in Antarctica. But actually, ski boots for cold weather was adapted from a spacesuit design to keep the astronauts warm or cool in the temperature extremes of the Apollo moon mission. So the original design came from the 1960 Apollo missions. And the idea was to actually thermally heat the gloves and boots. So there were little heaters inside as well to keep your hands and feet warm. And so the spacesuit design has actually led to lots and lots of clothing design, both for Antarctic wear and for skiing, etc. So that's another spin-off that we've seen. And these companies that I sometimes mention here, like Comfort Products, they would work with NASA to develop the technology. And of course, they're not going to develop something that's just going to go off once, but the need is there for an Apollo mission or a mission to the moon, etc., and then they develop it for our need on Earth. Moving on. This is a cushion. Okay, most of you have heard about memory foam. If you watch TV, you know, they're all encouraging you to buy a bed that when you lie on it, it remembers your shape and all of that. That's called memory foam, or there's another name for it as well, but it's mostly called memory foam. It was developed under a NASA contract in the 1970s, and they wanted to improve the seat cushioning and crash protection for airline pilots and passengers. Okay, so when you send an astronaut up into space, it's quite an intensive ride. It's not, when they say there's a little bit of turbulence, okay, a little bit of turbulence, it's quite a lot for them. And the memory foam was developed for that, was developed under that contract. It has widespread commercial applications, so in addition to popular mattresses and pillows. And over the last 40 years, There have been many technologies improving it in the space industry. So it's used in all sorts of things. In the International Space Station, which I'm going to talk about later. It's used in the little capsule that they put the astronauts in to send them up to space. They've found many applications for memory foam. And some of you are sleeping very nicely or with a nice cushion made from memory foam as well now. Right, the Dustbuster. Okay, so firstly, I promised NASA I would tell you that no, NASA didn't take a Dustbuster to the moon, okay, or to space, all right. But what they did do was they worked with Black & Decker to design tools for NASA. But NASA needed very special tools, and they needed battery-operated tools, cordless tools. And as a result of NASA's need for these tools and the work that they did with Black & Decker, there were several spin-offs, including the Dustbuster and other lightweight battery-powered precision medical instruments. And the research paved the way for the current cordless tools we have. The other example they use is the cordless drill as well, which is used in space, for example. The Dustbuster is one of the most famous ones. Most people know that the Dustbuster has something to do with space. And one of the myth busters is that, no, they didn't take it to space and clean up space with it. Right, then I think I've got another one coming, yes? Oh, yes, baby formula. So, here is some the standard stuff. Most of you who have children will know this stuff, baby formula. Okay, so baby formula contains an additive called formaldehyde, which is highly enriched in nutrients believed to be beneficial to infant mental and visual development. It really is. It isn't just because it says so on the label. Okay? And this additive is an offshoot of space research into food for astronauts. Feeding astronauts was one of the biggest problems that NASA had. And freeze-dried food, which I'm not using as an example here, also came about. Most people use it on hiking, etc., came about because they were looking for ways to feed astronauts in space. And so the additive that goes into your baby formula comes from that as well. Scratch-resistant glasses, such as most of us take for granted now, were developed by NASA. Now you can imagine, it's actually quite bright in space, even though, especially if you're looking at the reflection of the sun off the planet Earth, and we'll see a video in a minute about that. And NASA developed scratch-resistant lenses by applying a diamond-like lubricating coat over the plastic lenses. It was originally used in the space program in a dual ion beam bonding process to protect the astronauts' visors. And one of my favorite astronauts is a guy called Chris Hadfield, and we're going to see him in a minute as well. And he gives a very good YouTube video, if you ever have time, about how he went blind in space because there was a crack in one of his lenses, and he got some dust in there. He recovered, thankfully. Today, the coating is still used in hard resin plastic, used in most eyeglasses that people wear every day at the moment. Okay, and then golf. I have a golf ball here. You must just pretend this is an Ultra 500, which I believe is like a super special golf ball. So Babcock & Wilcox, which is a famous company for making golf clubs, produced composite materials originally from the shuttle program for improving golf clubs. So they didn't invent NASA didn't invent the golf club. They also didn't play golf in space, although that might have been quite an interesting experiment. But they did invent materials, composite materials, that were used then later by a company to improve golf clubs. These reinforced composites provided a combination of shaft rigidity and flexibility that apparently provided maximum distance, which is what you want when you're playing golf. The Ultra 500 golf ball, which is supposed to be one of the Rolls Royces of golf balls, was also designed with space know-how. And apparently, the Ultra 500 golf ball has a lot more little indentations on it than your average standard sports shop golf ball. Okay, so those are my 9 consumer spin-offs. I'm sure if you go and look at home and you go and Google, you'll find a whole lot more, and I could keep you busy all day. But Moving on, we can look at a few more high-tech spin-offs, some of which are still in the making, that I want to share with you that I found interesting. One of them was a spacesuit for a baby. So this is called I call it the Mama Goose, but I think it's actually supposed to be Mama Goose. Okay, Mama Goose pajama suit. It features a built-in cot death monitor and baby guarding system. So baby cot deaths is quite, unfortunately, a regular occurrence. And the idea of monitoring the heartbeat of your baby is the same. NASA or any space program that has astronauts in space want to continually monitor the heartbeat and the vital signs of the astronauts to make sure that they're not suffering any ill effects from being in space. And so this came about. This has been designed by a Belgian company in collaboration with the European Space Agency and the German Space Agency and a university. It draws on technologies used in 2 space applications. The one system records and analyzes biometric data, body movement data, and the other one was created to monitor the astronauts' breathing, to make sure that they were still breathing normally in space. Up to now, it's been developed for limited use in hospitals and research laboratories, but it's currently being developed as a consumer good, and eventually parents will be able to buy it to help them monitor the breathing of their babies. Of course, you have to attach your poor baby to this machine over here. And I assume the pajamas are comfortable. The baby doesn't look too upset. But that's one of the other offshoots. And there's a lot of medical spin-offs from space where they've used some of the technologies that they've done in space for medical use. The other famous one, which maybe some of you have heard about, is the Canadarm. Now, when you start a space agency, like we did in South Africa, you go and look at all different kinds of space agencies, and you have a look at, are they doing space agencies? Are they policy space agencies? What are they set up for? And the Canadian Space Agency is a similar size to the South African Space Agency. And when they started, they took the notion that they wanted to be remembered forever for one thing. They're going to be really, really good at one thing. And they decided to concentrate on robotics. And they designed this arm called the Canadarm. And the Canadarm has been used to fix the Hubble Space Telescope. It's been used on the International Space Station. It has made 90 successful missions to space. And they have a second version of it too, called Canadarm. It's the most famous robotic and technological achievement, and it made its space debut on the Space Shuttle Columbia in 1981, and after that it flew 90 times before it was sent out for retirement. It established Canada's international reputation for robotics innovation and know-how, and generated a family of Canadian robotics on board the International Space Station. Canada became famous for the Canadarm, and in the space world, when you talk about CSA, the Canadian Space Agency, everybody immediately thinks Canadarm. But it's a robotic arm. It's now been applied for new technologies for industry, medicine, and other applications which have been inspired by that arm. And I want to share with you a short video that I have on how the Canadarm is now being converted into a medical instrument that's going to help children all over the world.
Launched on March 11, 2008, Dexter is the most sophisticated space robot ever built. This extremely advanced, highly dexterous dual-armed robot carries out delicate maintenance and repair tasks on the International Space Station. Dexter, a descendant of Canadarm, has hands equipped with special sensors that give the robot's computers the ability to detect how hard it should push or pull and in what direction within millimeters of its target. Now, the technology behind Dexter is finding its way back to Earth. Researchers at the Hospital for Sick Children in Toronto partnered with McDonald, Detweiler and Associates to develop the initial prototype for KidsArm, the first image-guided robotic surgical arm in the world specifically designed for pediatric surgery. The new prototype is currently being tested, and researchers are hoping that the technology might soon lend a helping hand to pediatric surgeons around the country. The surgical robot is operated using a pair of hand controllers in conjunction with high-precision, real-time imaging technology. Equipped with miniaturized dexterous tools that can cut, coagulate, apply suction, or use a laser, Kid's arm is capable of working 10 times faster and with more accuracy than a surgeon's hands to perform intricate procedures such as the suturing of blood vessels and tissues. While more testing is needed, the robot is promising for fetal, neurological, cardiac, and urological surgeries. One day, this technology may help children by making medical procedures less invasive and less painful, allowing them to return home faster so that kids can be kids. Canadian Space Agency, thinking outside of the globe.
Okay, so that's one of the medical applications that will be direct spin-offs from space. Some more spin-offs. So when Apollo 12 landed on the moon, the astronauts deployed a special lunar surface magnetometer. Now, if you've been on a tour here before, or if you go on the tour after this, you will go to our magnetic area at the back there. You'll see that one of the things that this facility does a lot of is magnetometry. So you have a lot of magnetometers, we measure the Earth's magnetic field, and we do a lot of work around magnetic technology, and that's part of our space spin-off, and I will show you that in a minute. Now, they do that at NASA as well. NASA Amos is their research and innovation center, where they do a lot of, where they apply a lot of these spin-offs. And they had, when Apollo 12 landed on the moon, this magnetometer that they took with them had to measure the moon's magnetic fields. They wanted to deploy something that could measure the moon's magnetic fields, but to do that, they had to test it before it could go up there. And so they had a pair of buildings where magnetism can be manipulated. At the Amos, and we have a similar set of buildings at the back here, except we don't use the word manipulated. Okay, we don't mess with the magnetic field, but we try to sometimes take it out of the equation so that we can get an absolute value of the Earth's magnetic field. And you need a special building to do that, a magnetically free building, or magnetically friendly building, magnetically clean building. So they have those buildings, and these buildings have now been taken over. They're still part of NASA, but as part of a Space Act agreement, they've been taken over by this company called Geometrics, Inc., who are using them as a test facility for its magnetometers. And they are using those magnetometers to find magnetic anomalies in soil and water. So again, that's another spin-off that came from the Apollo mission. And the company is also using these devices to find buried objects and calibrate underground drill rigs. And I'll show you in a minute how South Africa has done something similar as well. And then those of you who know me know that I quite like coffee, right? So my next one is a coffee maker that's come out of the space spin-off. And I really like this one, even though it's a little bit off the topic maybe. But there was NASA Amos is where all the young, bright, you want to work for space. If you ask a young person, even in South Africa, we've got 2 South Africans who are on this internship program at NASA at the moment, where they want to go and learn about space. Everybody always says NASA Amos, because they have a lot of really cool young people doing amazing things. And there was this guy, Matt Welliser, who spent 4 summer internships at NASA. And in that time, he developed various skills related to building intelligent, autonomous robotic systems. So a lot of that is software controlled, working out how to make the robot do what you need it to do. And some of these systems, like this very fancy thing here, proportional integral derivative controllers and embedded communications, were used to start a Blossom 1 coffee brewer, which is where this guy is now the chief engineer. So he used what he learned at NASA to set up a company to make a coffee brewer, and that's what it looks like now. The technology holds the brew temperatures constant, ensuring consistent results, and allows the machine to brew according to recipes stored online. So you can decide that you like your coffee like this. This is the most brilliant cup of coffee you've ever had. You then tell the machine this, it stores the recipe, and next time it makes you the exact same cup of coffee. Okay. And it came from working in the space industry. So I kind of like that. I thought that was quite cool. Yeah. Okay, so let's go closer to home. Since we are sitting in the space agency, South Africa's space and spin-offs from that. And there's quite a lot of things I can talk about here, so I've only chosen a few of them, and I've gone further afield than just this facility. One of the things that is of big concern to the Overstrand, of course, is fire. And I think most of us have been touched by fire at some point. So one of the things we're doing in South Africa is we're looking at how to use space to help us control forest fires and help us deal with climate change. So, as you know, Africa is the continent of wildfire. 70% of the global total area is burned by wildfire each year. And the occurrence of fire in Africa is controlled largely by climate. Okay, we say largely because a lot of people cause fires themselves as well. In 2008, 45 people were killed and nearly 200 homes were destroyed by wildfire in Mozambique and South Africa alone. So we use space, a space solution. We have developed a product using space imagery, so Earth observation imagery that we've collected from space, to develop a program that will allow us to look at where the hotspots are for fire and get resources out there quicker, so that we can control the extent of the fire. So this is a fire investigation map from 2015. Showing the country and the different provinces, and then these are areas that show Earth observation imagery that they've now gone into, zoomed into, to look at areas around where the fire is happening. And so there is a big move and a big project in South Africa at the moment called AFIS, African Fire Information Systems, looking at how do we use Earth observation data more immediately to help us detect fires when they are about to happen, not after they have destroyed a whole lot of information. So that's one of the local space solutions. Another local space solution, which is happening right here in this facility now, is mapping. So looking at the knowledge and measurements of the Earth's magnetic field, which we need for the space work that we do, to develop magnetic inclination and declination maps and magnetic variations at certain locations. And you might ask, well, who cares? Why is that important? Well, one of the reasons you can land accurately at an airport is because they have an accurate map of that airport that shows how the magnetic field lines are moving. So we use the magnetic variations. Mostly the magnetic variation work is done for accurate mapping at airports. We also use it for beacons, for ships, for surveillance. And these maps that you see down here show you how the magnetic field is decreasing with time, and it also shows you the areas over which we measure it. We're currently working with the Air Traffic Navigation Services, ATNS, to look at how we can better apply magnetic variations to remapping all the airports in South Africa to make sure that those locations that the pilots are given for landing is accurate. So that's one of the space solutions, accurate positioning. Another one is, which is very strange sometimes you think about, is cathodic protection for ships. So your ship, your vessel, any kind of metal, of course, has an ability to corrode. And if that vessel happens to have half of it in the water half of the time, then it has a more likely chance of corroding. And so one of the things that we do together with the South African Navy is we use our space know-how to do magnetic and electric signature management on ships, which provides any indication of a problem with the cathodic protection system on the vessel. So by detecting these problems, these corrosion problems, we can save the Navy millions of rand worth of damage to the vessels each year. And so that's one of the also solutions that came out of, we know about space, we know about magnetic fields, and we found a problem that we then brought a space solution to. One of the things that you will see when you go on the tour is a magnetic test bench that was developed by this facility. This magnetic test bench allows for the evaluation of aircraft compasses. In the past, if you wanted to evaluate your aircraft compass, you would have to take your aircraft, the whole thing, and move it to a very special magnetically clean area, and then you would have to get a large number of very big people to rotate the aircraft in a certain direction so that you could get a sense of what the compass was reading and its accuracy. And this required several trained personnel. You couldn't just get anybody to move your aircraft. And so in 2006, SANSA developed and patented a magnetic test bench that allows the aircraft compass to be evaluated and corrections to that compass be made on a table. When you go out on the tour, they will show you the magnetic test bench and how it works as well. But that's also one of the space solutions that is currently in use largely by the South African Air Force. And then a few other fun things that we do with space. We've used our magnetometers and our magnetic know-how to search for early civilization on Robben Island using a scalar gradiometer. We've also helped Iziko museums to look for a stranded slave ship. I'm not sure if we found the ship, but we did go looking. Okay, and then we've done some very interesting work in looking at whether or not electric and field measurements can be used as reef barriers for sharks. And that's done over there. So we don't only use space to investigate space or to do things related to being in space. We're also looking at how can we use our space know-how to help man on the ground. You will also on the tour go to our Space Weather Center, and in the Space Weather Center you will see high frequency communications is one of the products that we produce from there. And these so we don't only produce space weather forecasts, space weather predictions, what's going on in space for the fun of it. We also do it in order for there to be applications from it. And one of the applications that is a space solution is to look at how does a communication path change with what's happening in space, and how can we then advise those people who are using the paths to then make changes depending on what's going on in space. So high frequency communications is dependent on the Earth's atmosphere, which is in turn affected by space weather. So you have adverse space weather, so when something goes wrong, or not goes wrong, when there is bad space weather or a space weather event occurs, it means a change in communication plan or paths, and so we've developed applications that can be used to monitor these changes and make suitable predictions. And this is some of the results from those applications here. Again, when you go on the tour, you will see the Space Weather Center, and they will show you some of these very similar graphs that you will see there. So there's also a space solution to high-frequency communications. At the moment, this is applied primarily ground-to-ground communications, so for the defense sector and for amateur radio operators, etc. But very, very soon we're going to be applying it for aviation as well, so air-to-ground as well. Because as most of you probably don't know, or maybe you don't know, that all passenger aircrafts has to have HF communication as a backup plan when they fly. Right, then just on the space industry side of things, I wanted a few more slides on the space industry, but unfortunately I didn't get all the information I needed. But one of the things that SANSA is trying to do is to stimulate the space industry in South Africa. And the space industry in South Africa is growing. And a large part of it is growing in the Western Cape. And by space industry, I'm typically talking about people who are building satellites or building subsystems for satellites, or looking at how do you build components that are hardened to take up the space environment. And so there's a number of those companies that have sprung up and are working on that. But of course, South Africa doesn't have a large satellite roadmap. So they do a lot of work internationally, and they also do a lot of work for the aerospace sector. So one of the spin-offs is the space industry's skills being available to the aero industry. But another spin-off, which most people don't know, is that of CubeSats. CubeSats has become the very popular version of a little satellite. A CubeSat is a 10 by 10 by 10 satellite. It's the size of a third of a loaf of bread. So, well, a 1U cube is a third of a loaf of bread. If you have three cubes, you have one loaf of bread. And basically the idea is that it is cost effective to build. You can do the development, the design, the concept, build it and launch it into space in the lifetime of a student's degree, which means that we can develop satellite engineers and space engineers who are still in the industry when their satellite actually gets launched into space. And CPUT, the Cape Peninsula University of Technology, was the first university in South Africa to start this program. There are now 4 or 5 different entities, companies and universities who are building CubeSats at the moment in South Africa. It's becoming a budding industry. SANSA is helping not by building the CubeSats but by giving them ideas for payloads so that we have useful CubeSats in space. And so this is an example of South Africa's first CubeSat. It was launched in November 2013. It has a payload on board that is a beacon, HF beacon, operating on, I think, 14 megahertz. And the idea behind it was that it would calibrate our Antarctic radar system. And this is the Antarctic radar antenna that you see here. It was a successful mission. CubeSats are supposed to have a lifetime of about 3 months, actually. So it seems like a lot of effort to put something in space for only 3 months. But 3 months is like the conservative estimate, and we're still talking to the CubeSat, and it's been up for more than 2 years now. So sometimes you get lucky like that, and the lifetime is a bit more, etc. But they're busy working on a second. This is called ZAQB1. It was codenamed ZAQB1 and ended up being called CHIPISO-SAT. ZAQB2 is under development at the moment. The amateur radio community is also developing a CubeSat at the moment. So is Denel. The Denel Training Academy is also doing a CubeSat, and the University of Stellenbosch is building a CubeSat, and there's quite a few other entities in South Africa that are doing that. And later this year, we will host here at SANSA a workshop for all these entities to come together to discuss their different CubeSat ideas. So that's also one of the stimulating spin-offs. Okay, so now social spin-offs. It is really, really very fun and cool to work in space. Okay, I don't look very excited at the moment, but it really is, okay? So there's a lot of spin-offs that we don't realize when we talk about things like this. For example, education. So here in SANSA, we say we use space as a driver to create excitement in science and technology. And we do. So we know that not every child that visits the space agency is going to become a space physicist. But this country really needs people to do, and young people to do science and maths at school, to become engineers, to become other scientists, also for space, but in all sorts of areas, to become doctors, to whatever they do. Choosing maths and science early in school gives them a lot of career options. Okay? So how do you get a child to be excited about something that they've almost programmed from birth to believe is difficult? All right? So we try to use within our science center and the activities we do with children, and when we talk about space, we use the coolness of space, the mystery of space, the inspiration of space to drive that excitement in science and technology, and to persuade the youth to pursue STEM. STEM is the political word for science, technology, engineering, and mathematics. It's because we have to say it a lot, and if you say science, technology, engineering, and mathematics a lot, you run out of breath. So we say STEM for short. And this is some of the activities we hosted here. And when you walk around today, look at the excitement on those kids' faces when they are building a little rocket or building a little kit or working with their hands. And they are doing something that is related to space, but actually they're doing something that's related to science and technology. And we're looking at our future engineers and scientists. And for me, that's a major spin-off of being in the space industry. Innovation, research, and development. Now, innovation is very, very important for a country like South Africa, for sustainable development. The theme for National Science Week is sustainable development, and for sustainable development you need innovation, and you need room for innovation. You need people to be able to grow, people to be able to feel comfortable to put their ideas on the table, to create those spin-offs, to say, okay, you need this for space, but we can also use this for something else. And so the space industry provides exciting projects that develop and apply space solutions to everyday challenges. So it gives that room, it gives that freedom for innovation and inspiration. Some examples I've got here is navigation, finding more accurate, efficient solutions to navigation for aviation. Currently, we're investigating a satellite-based augmentation system for landing aircraft. using satellites. And this project has got the engineers so excited, and they're coming up with really, really innovative solutions for how to do this, that it's really great. Energy, protecting the power grid network from space weather. Another exciting project we have on the go at the moment is looking at the impact of space weather on the power grid. Health and safety, so using imagery to detect disease spread and magnetic data to ensure accurate land mapping. Those are all solutions that we in the space industry can find for challenges that are out there, and it lends itself to innovation. So that brings me to skills development. So these are some of our SANSA students, all looking very happy. We didn't make them look happy, we just, they naturally look happy. So space also provides a platform for developing a knowledge economy, and knowledge is power, so it's getting the knowledge out there. It's the development of a workforce with transferable skills. If you're going to put something in space, or even utilize space from the ground, there's a lot of things you have to overcome. There's a lot of challenges you have to face. There's a lot of problems you have to solve. So you learn to solve problems. You learn skills that you can apply in a lot of different industries. And that's one of the things that we are contributing, is a workforce with transferable skills. And then a stimulated industry that excites the next generation is also, all the time that we're working in the space industry, we realize the young people we're exciting are our next generation of scientists and engineers. And somebody that is at this open day today, and is under the age of 15, will probably be one of the next space agency CEOs. I like that idea. Okay, I'm nearly done. I can see my usher is looking at his watch and getting very nervous. Inspiration. So space inspires, it attracts, it's mysterious, it appeals to the curiosity factor, and it still has many unanswered questions. And all new scientists want to know, what is the question that I can answer that nobody else has answered before? The International Space Station is one of those things that has really inspired generations. Just a few facts about the International Space Station. I'm nearly at the end of my presentation now, but I wanted to end with this. The International Space Station is the most complex international scientific and engineering project in history, and is the largest structure humans have ever put into space. It was sent to space piece by piece and then actually assembled in space. It's a laboratory for new technologies and an observational platform. And it's a permanently occupied outpost in space. So we send astronauts as in the global we, astronauts go to space to work on the International Space Station in the same way that we send people to Antarctica. Okay? We say they go there for 6 months or 8 months, and they do experiments. They learn how does the body respond in space. They learn how coding happens in space. They are using the International Space Station to launch satellites now as well into space for a whole lot of other things. The International Space Station flies at an average altitude of 400 kilometers above the Earth. It circles the globe every 90 minutes at a speed of about 28,000 kilometers per hour. If you go to Google and you look for Space Tracker, you can get a program that tells you how to know when the International Space Station is flying overhead, and you can see it yourself. In one day, the station travels about the distance it would take to go from the Earth to the Moon and back. It was built by 5 different space agencies representing 15 countries, and it cost $100 billion US. And they continue to operate today. So the big boys in this game is NASA, Roscosmos, which is the Russian space agency, the European Space Agency, the Canadian Space Agency, and the Japanese Space Agency. And it's been continuously occupied since the 2nd of November 2000. So for the past 16 years, there's continuously been somebody on the International Space Station. And if we had a lot of other time, I would have played you some more videos about how life works on the International Space Station. And it's quite fascinating to see. There's a lot of information on the internet about it. But this is also one of those things that has inspired generations. If we, as the current generation, can put a laboratory of this size in space, do the kind of experiments we've done, create the kind of technologies that make our life going forward easier, can you imagine what the next generation can do? And that's what's inspirational. So I'm going to end my presentation with another small video for you. Chris Hadfield is a Canadian astronaut. He was the first Canadian to go to the International Space Station, ISS International Space Station. He was also the former commander of the ISS from for the year 2013. He was commander of the ISS. He's done a lot for inspiring the youth in space. He did a lot of educational videos on very basic things like how do I brush my teeth in space and things like that. And so if you have children or you're interested yourself, go and look up his YouTube site. He has a lot of very inspirational things. But then he also popularized space. He did, and I'm not going to play it for you here because it will take too long, but most of you might remember that he did a rendition of Space Odyssey, playing it from the space station. And it was filmed all over the world and even made it onto SABC News. So when he was up there as the commander. And so here he is. I've just taken a snapshot from one of his songs called ISS. It's called Is Somebody Singing? But it could also mean International Space Station. Just to give you a sense of what his feeling was about looking at Earth from the International Space Station, which is one of our largest inspirational systems.
I see, look out my window, there goes home. That ball of shiny blue houses everybody anybody ever knew. So sing your song, I'm listening. Out where stars are listening, I can hear your voices bouncing off the moon. If you could see our nation from the International Space Station, you know why I want to get back soon.
So I would like to acknowledge NASA. Those are the websites from where I got a lot of information. Chris Hadfield also gave me lots and lots of information. By the way, there is a very, very good book that he wrote called An Astronaut's Guide to Life on Earth, which anybody can read. It makes a very, very good read. And then Goldfish, who did the Moon Walkaway video at the beginning, the Canadian Space Agency for their video on the Canadian arm, and the German Space Agency for the information on the baby's spacesuit. And I hope that this has given you a little bit of a sense of why we here feel that it's inspirational to work in space and what space can mean in your lives. And maybe when you go home, you will look at things a little bit differently and wonder, where did that actually come from? How did we end up getting there today? Thank you very much.